Alright, let's get started. So today I want to finish up that Tic Tac Toe series that we were making in the console. And today I want to implement the AI, and the algorithm that we're going to be using for this video is Minimax. It's really popular for AI like Tic Tac Toe because it's fairly simple and it doesn't take that much logic to understand. I'll explain a little bit, but I'll link a video top right corner right about now where I saw this concept and where I like really learned it, and I think it's a really good video regarding minimax alpha beta pruning, that type of thing. So yeah, it's a recursive algorithm, and you can see the Wikipedia Wikipedia page. The minimax, the whole point of it is to maximize your winning and minimize the loss, and I'll show you how that works. So I pulled this image out of Google Images that I really liked. I'll put a link to their website in the description if you want to check it out. But how Minimax relies on, thinking is it gives grades to each state. So how it does that, you take the current board state that you have right now. And even before that, actually, you first need to figure out who's the maximizing player and who's the minimizing. Who is trying to maximize their winning and who is trying to minimize. So the AI will be maximizing and the player will be minimizing. So we can just say, I think O, we're making O the AI, so I'll say O, or well, in this case, X. X is maximizing, and then we have O as minimizing. So in essence, a move here where X moves, it's a maximizing move. And then this next sequence of moves where O moves, O is trying to minimize X's winnings, right? Trying to give him the maximum loss. And then you have O moving again as the maximizing player's move. And then the next step is you have to figure out a scoring system for end states. So in Tic Tac Toe, we have 3 end states: X wins, O wins, and if there's a draw. So in this case, the X is the maximizing player. So anytime X wins, we're going to say it's a positive 1. Anytime O wins, we'll say a negative 1. And anytime there's a draw, we'll say 0. So we take the current state, and X, how this algorithm, how we're going to write it, I guess, it checks each possible spot. So X goes here, so it kind of creates a tree because it's a recursive algorithm, right? So X tries here and then goes down, tries here and goes down, tries here. And for each state, it will create a grading system, and it will fill in each spot, each possible combination of moves that X and O can make from this, top of the tree spot. So it will, check every combination and grade it. So it goes down the tree. So I'll just give an example. X moves here, for example, and then O moves to the top. We give the end state a -1. Then we go to the other side. We say, let's say O moves to this right edge, and then X moves, we'll say +1. And then here you can see it's the end state of the tree. So when a tree when like a branch, there's only one branch and there's not two, this score just carries up to the kind of parent. Since it's not 2, you see how this is 2 and this is 3, but this is only 1, so we just carry up the score up to here. So this board state is also given a score of 1. And now we see what we have here. We have over here, how do we get -1? You see it's the minimizing player's turn. So the minimizing player wants to find the minimum between both of these scores. So -1 and 1, obviously the smaller one is 1. Hence we give the score -1 to this board state. And then we can do the same thing here. I'll just run this example. So let's say X moves here, then O moves here, and then X moves here. It's a tie since it's only one branch. Score carries up to here to 0. And here O and then X. We give this board state as a 1 since x has 1. X has won this match. All these ones and negative ones and winning. Oh my god, it's so confusing. Anyways, this score carries up, and then O is the minimizing player, finds the minimum score, and the minimum between 0 and positive 1 is 0. That's why we have 0 over here. And then we try this last spot, and then we give O the opportunity of moving. If they pick the top right corner, then O wins, and we'll mark this board state as a negative 1. And if we go down, we see that if O moves to the top edge over here, and then X moves, it's a tie, and this score carries up to here. And then O is the minimizing player, finds the minimum between 0 and negative 1 right here. And then X is the maximizing player, so it will find the maximum scores from all of its child permutations, I guess you could say. So the maximum is obviously 0, so 0. So I hope that makes sense, but I did link that video that goes a little bit more in depth on how Minimax works. So let's start coding this AI. So this is a long-awaited video, so I'm going to try to remember how I wrote this script. But yeah. So here's how our main kind of main.py file looks like. So I just hope everything's the same. It looks like it. So yeah, let's start writing the AI script. So first of all, I just deleted everything because I just want a fresh start so I could kind of be more in a flow, if you know what I mean, while writing. So we want to import all of these important methods from methods and slash data from the board file. So we want that main board. Let me just see what it looks like. Did I have board in all caps? Yeah. Okay. And then we want to basically create this dictionary right off the bat so we could do our grading. So we could put it a part of our class, but you know what? Interpretations. And I'm just going to put it up here. Because why not? And X has to be capital. So really the point is that our method that we wrote before of is when, it either returns an X, O, a tie, or none. So we want to create a dictionary that accounts for X, O, and tie. And since it puts in capital X's, we would like, we like a capital O and X. So we need X to be -1 because again the AI is an O. And then O is a win, and if it's a tie, then we will say 0. Alright, let's create this class, AI, and then we'll create the constructor method, and self, and then we'll self.name, and we'll set it to code talks. You could set it to your name, whatever you want, doesn't really matter. And then we'll print out you are playing code talks. Yeah, we definitely did that last time. Is there a comma in my name, like my YouTube username? I don't know, someone comment down below. Alright, and then let's start our method. So our move method. So we're gonna do def move, and then it's just gonna be self. And then we'll just, you know, as a good message, tell the user who's thinking. So I'll just create a quick F string. Self.name is thinking. Self.name. Do I need a comma? No, I think that's perfectly fine grammar. Okay, and then what else do we want to do? So I think we should create the board copy just so we're not editing the official board. No, just for good measure, just in case we don't mess stuff up, because the way I'm thinking of doing this, exactly know per se how I'm gonna do this, but I just have I have an idea how Minimax works, and implementation I'm just gonna figure out as we go. Okay, so here's the first part of Minimax. So as the maximizing player, we want to find the highest score, and the initial value of our highest score, we're just gonna set it to -infinity, because we want at least a score higher than -infinity. So we just need to initialize it to that, and then spot that we want to go to, we just set it to -1 for now, but this is like the spot that's most optimal for the AI. And then we'll set a variable just called RAM, and we'll set it to nothing for now. And you know what, we could set RAM in there later, I feel like, because we don't need RAM until inside the loop that will go through each spot in the board. So we'll create a nested loop, and then what we'll do, the first thing right away, we'll create that variable called RAM, and we'll say board copy ij, because it's a 2D array, and then we want to check if this spot is available. So if RAM does not equal X, and you know what, I feel like it would be better if we did this. So we do this, so basically we're checking if the spot is available, as I said. And then what we can do is we can put this RAM thing down here. That would make a little more sense, I feel like. And then we're gonna just make the board copy, like the current spot. We'll make the current spot O, just to test Minimax, kind of like I was saying in these permutations. We're gonna test each available spot and put our marker O over there. So we'll just set this to O. And then the spot is open. Then we want to score this board. Kind of sounded like smorgasbord. All right. It's current. We want to get the current score of this board. So we'll set that to. We'll create a method called Minimax. And then Minimax takes in 3 arguments. So it takes in the board. It takes in the depth, like where we are. Depth. We don't type depth, we start at 0. And then it takes in if the maximizing player is the next turn or the minimizing player. So we just tested this spot, right? So what we did by testing this spot is we moved as the maximizing player, so now it's the minimizing player's turn, so we'll set this to false. I'll just quickly write the method header so everyone knows what I'm talking about. Minimax takes in self, the board, the depth, and is, you know what, I'm just going to type in camel case, because Java. Maximizing. So is maximizing, we'll figure out, you know, is it the maximizing player's turn or the minimizing player's turn? Okay, and now what we want to do is we want to set board.copy back to what it was. So you're just going to copy this and set it to RAM. Alright, we just want to set it back, because when we're going to the next open spot, we want the board state to, we don't want this board state to reflect this move. That's why we have to erase this move when we're checking for the next kind of child branch. And then what would we want to do? Under this if statement, we would definitely want to check what our biggest score is so far. So if current score is greater than highest score, then what we would like to do is set highest score to the current score. I feel like we didn't need to create a board copy, but it's fine. I was just thinking, just in case. And we'll set the spot, the sweet spot. I feel like we should call it sweet spot. I'm not going to waste time like that. So we'll set board IJ. That's what the spot is going to be. And then once we're done with all of this, checking each permutation and scoring, we found the best spot. We want to use the update method we wrote in the board file. And we want to pass in the int spot. I'm pretty sure it takes an integer. I'm 99% sure. Update takes an n, and my dict takes numbers, so we need to pass in an int version of spot because our array contains strings, as we know. And then since we are O's, we're passing false. Okay, now let's write the maximizing the minimax method. So each recursive method always has a terminal condition. That's just like recursion 1.0. No, recursion 101. And I will be uploading this, uploading the next video as probably like a Pygame version. So yeah, I don't know. We'll see. And then what we want to return. So here's what I'm doing here. If is win doesn't equal none. So if we reached a terminal condition, we want to return basically our interpretation of that condition. So we'll just use our dictionary that we created, and we return interpretations, and then we wrote what is win is, and is win is a method. So we want to return is win, right? Yeah, so that's the terminal condition. Now let's do the minimax part. So this is going to be for the maximizing. I definitely butchered that. I'll just maximizing. Why does that look so wrong? Maximizing. Spelling, words. That's why I just stick to coding. Easier. If is maximizing. So if it's the maximizing player's turn, we will, do like literally the same thing, I feel like. We don't need the spot variable, so we'll get rid of that. But we definitely do need this whole minimax thing going on. I'm just gonna copy this whole thing, paste it, and then edit it. Okay, we don't need the spot, as I said, because we just want the score. We don't really want what spot. Okay, and then we would like to see, oh my god, my spacing is so horrible, but you know what? It's fine. We want a quick video. No, this is annoying me. Now, we should be good here. Then we should be good here. Get the current score. Set the board back equal to round. Then what do we want to know? And then we want to use Python's beautiful max function and do highest score and current score. We'll just look at that. Yeah, that looks about right. We'll just say else, and we just can copy this whole thing. Oh, we just forgot like the most important thing. After we're done figuring out the maximizing player score, we would like to return the high score. That's the whole point of this. So I'm just gonna recopy that. Change all of this to lowest. Comment down below some good Visual Studio shortcuts. I just started using it because, as you all know, I'm a PyCharm guy, but people have been telling me VS Code is much better, and I'm starting to use it for a lot of my projects. Okay, and here we want to do depth plus 1 because we're going into the next depth. I just realized that just by looking. Look at us just debugging on the go. Depth plus 1. And then the next player is maximizing, and the lowest score should be initialized to infinity. This should be the minimum because it's minimizing. Just write a comment here. Minimizing. No, minimizing. Yes, I think, hopefully. And then we want to return lowest score, not highest score. Lowest score. That looks good enough to me, I think. So, yeah, let's test it out. Kind of want to test it out in CMD because that's my, jam. Just running stuff in CMD. Or you know what? Let's just run it in VS Code. Why not? Why not? I don't know what happened. Comment down below what happened. Okay, let's run this. Oh, did I just mess up the first line? That is sad. That is really sad. I apologize for that. Come on. What is our name? We'll just say CT for code talks. Board copy is not defined. What? Did I not create a board copy? It's literally right here. I literally see board copy right here. Like, am I tripping? Let me just see where it's saying this. What line is there on 66? Oh, okay, this is just because this is all supposed to be board. It's gonna be a lot of editing, guys. And the best part is, I'm not gonna fast forward any of it. I'm sorry, okay, I'll be quick. We want this to be board, we want this to be board, and this to be board. Are there any more board copies? Don't see anything. So we want this to be board. 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 I'm bored. Do I see any more boards? Nope. We should be good. I'm gonna create a programming language that has a control Z on variable reinitializations. Doesn't go back to the previous initialization. Probably be a really inefficient language, but where are we? Line 70. We definitely did the same thing. Oh, I know where we did this in the minimizing part. I'm 100% sure. We wrote high score here. Yeah, I knew it. I literally knew it. Lowest. No, did you run AI? Who did you run? What did you run? No, not AI.py, bro. Why would you ever run AI.py? That's fully my fault. You know what? We're gonna do it a different way. Python main.py. It's gonna work when I do it like that every time. It's a proven fact. CT. Oh my god. Current score. Where? Where, man? Where? line 70. Line 70, lowest score, current score, and then there should be current score, not lowest score. I don't know why I'd change that. That literally makes absolutely no, don't run AI.py. Everyone knows AI.py is not going to make a mistake. Python main.py. I'm definitely going to look like such a fool because I can get all these like VS Code errors just because I don't know how VS Code works. Alright, we're thinking. Move to the top left corner. Where do I want to move? Let's just try moving to spot 3. Okay. It moved to 2. Why did you move to 2? No, I guess that might actually be not a bad strat. Think about it. If I move anywhere but 5, so let's say I move like, if I move to 6, then it should work, but it doesn't, because I want. Alright, this outputting is also kind of making me. Okay. What is the situation? We don't want to print board after this. Where did I write Minimax incorrectly? Is the real question. Did I set Minimax to false first? I definitely did this. I know what I did. I've set this to X, didn't I? I knew it. I knew it. I knew it. Like, just great. Like, it's so obvious, these errors. I don't even have to look at the logic errors. I just feel like, you know what? We're using CMD. I don't like it. I don't like VS. This is probably the last video you're seeing me with VS Code. Sorry. Bad experience. CD documents. Python scripts. And then CD TIC TAC. No. TIC TAC TOE. And then we want to do Python main. Statistics show when you run Python in CMD, you never get any errors. It always works properly every single time. So you can see it's thinking. Now it's more like it, because when I was running in the VS Code, I was like, why did that make a decision so quickly? Like, it made the right decision. Top left corner is definitely the best first move. But it made it so quick because we're not using any pruning techniques or anything. So it should check all of the possible combinations, and that's why you see it's taking so long. I mean, usually like a lot of implementation of Minimax let the player go first for a reason, but I don't know. I just like seeing the computer beat me. We'll move to spot 2. You can see it move to spot 4 over here, and then if I move to 3, it should move to 7. Oh, okay, I see what it's doing here. It's just like creating 2 wins because it gave it a higher score, but still not worried because it created 2 ways to win. I see, smart. And we created 3 ways to win. Okay, I'm actually kind of impressed. 6, and you can see it 1. Anyways, hope you enjoyed the video. Please like, comment, and subscribe. And yeah, let me know if you want to see like a GUI version with like Pygames with like, or add in like socket or something people can play over, you know, on different computers against each other. Let me know down in the comment section down below. But as always, please like, comment, subscribe, and share. And thank you very much for watching.